So we're going to start off with section 1.1, which is all about the anatomy of the Cartesian graph. Well, it starts off about the Cartesian plane anyhow. Most of this is going to be review from stuff we know in the past. For example, the anatomy of the Cartesian plane. It has a y-axis, it has an x-axis, it has 4 quadrants that move counterclockwise. It has an origin where the 2 axes meet. Like the Shannon Wow guy for the weatherman right now. Just some of the basics, like I said. We're not going to go too crazy into the lecture today. If you decided you were to use this, though, and wanted to plot some data, then you would say, all right, cool. I've got a collection of points, and these points represent X, Y locations, right? The first value would represent your location in the X axis, and then the second value represents your location in the Y axis. The way we would use this is we would say, let's take the point -1, 2. We're going to go along the x-axis in the -1 direction, and then up the y-axis in 2 units. And that's where we would put our point, right? Does that make sense what I mean? Where those 2 values would intersect would be the point. Is everybody cool with this idea? Yep. Cool. So we could apply this in the business world if we should like. We could say something like, we've got a bunch of data that represents some quantity as a function of time. And in that case, we would rewrite each of these as a point T A. Then we would say, cool. On our graph, we've got our t-axis, we've got our a-axis. We'd find where these points go according to that. Yeah. Having said that, notice you've got these little heartbeat monitor looking signs down here. This just means we're going to skip an ass ton of numbers. That's all it means. We don't want to go and list off the first 600 values, so skip them, jump straight to 600. Here we don't want to list the first 19,000. We don't want to list off the first 1,997 values, so skip them and go straight to it. That's all this means.
Yeah.
Awesome. How was the walk?
It was fun. It was great. It was sort of a janky little basement room.
Was it the one in the health building?
In the
In the health building that like had the tiny.
yeah, the one that looks like it's in a creepy basement.
Yeah, that's actually the murder dungeon.
Yeah, I noticed that's where we were.
That's where they keep the cadavers. And
He's still on the floor. Is this your tactic to weed out kids?
oh, obviously. No.
I know.
Are there not really? Okay. We will talk to building management about that stuff.
Just like a chair, but not a chair.
So this has come up in a couple other classrooms. Apparently, when everything was online, they took out desks, and not only did they were they like every other desk could be sat in, they took out a handful of it as well.
Yeah.
But sorry about that.
We'll pretend that's not happening.
The weird dungeon basement thing, or
Just, like,
the
pretty much everything since 9:30 has been weird.
sorry about that.
It's fine.
Sorry about that. Getting back in the lecture though, this is going to be a fun class. I can tell already. This is going to be a fun class. So let's say we wanted to plot this data. Like I said, we could plot them as points, or we can go ahead and plot them as a bar graph or a line graph if we so choose. Notice the only difference between a bar graph, just plotting the points, And a line graph is a line graph connects the points. Everybody's favorite game, connect the dots. So with that in mind, a natural question might occur when we start plotting things, how far apart are they? Looking at this, we might notice there seems to be a right angle triangle here, which should scream to us Pythagorean theorem right away. And in particular, what we should also notice is that the difference of these y values, taking the absolute value of that, gives you the length of this leg. And the absolute value of the difference of the x values gives you the length of that leg. So if we wanted to find d, according to the Pythagorean theorem, we would take the length of this leg, square it, add to it the length of this leg squared, and then take the square root of that, right? Because of course, Pythagorean, everybody's favorite Greek mathematician. I don't know, is that true? Like just, no, nobody likes Pythagoras, okay, fair. So what the Pythagorean theorem tells us is that a squared plus b squared is equal to c squared. We all know this. We can apply it here and say, so the square of the absolute value of the difference of x and the differences of y, if you square those absolute values and then take the square root of their sums, that'll give you the length of d. And that is in fact what we do here. So the distance formula between 2 points is just the square root of the sum of the differences squared. So putting this to use really quick, we've got 2 points up here, -2, 1, and 3, 4. -2, 1, comma, 3, 4. First thing we're going to do is take the difference of the x values and apply the absolute value to that. So the absolute value of 3 minus -2, this is going to be the absolute value of 5, which is just 5. Now, let me actually write it like this. This is x2 minus x1. Now doing that with the y values, we're going to have 4 minus 1. This is going to come out to be the absolute value of 3, which is just 3. And this is equal, of course, to y2 minus y1. So we can go from here and say, let's square these, add those squares together, and take the square root. That's going to look something like this. The square root of 5 squared plus 3 squared is going to be the square root of 25 plus 9, or just the square root of 34. So when it comes to homework, how do I, yes, ma'am.
Could you go back to the distance formulas?
Yeah, absolutely. When it comes to homework, how do I expect you to give these answers? Honestly, this will work. That said, WebAssembly can be particular, to say the least. And in that case, I don't know. If it doesn't accept the square root of 34, the next thing I would suggest doing is typing in the decimal value approximated to 2 decimals or 3 decimals. If that doesn't work, we're going to have to play with it. Go ahead, email me if you're confident about your answer. Just shoot me an email. hey, why is this not working? And we can figure it out from there. When I get my office hours figured out, by all means, drop by my office hours and be like, hey, this should work, I thought. Why isn't it? And we'll look into it. It might be that instead of 34, it's expecting 5.81-ish as an answer. Oh, damn, I was right, almost, 5.83. It might be that instead of taking the square root of 34, it expects you to write in the decimal. Or it might be that somewhere in there, a mistake was made in the math. But for those reasons, like I said, by all means, shoot me an email. Stop by office hours when I figure it out. And we will figure the problem out. Cool? Makes sense what I mean? Awesome. So what about in the case where we have a bunch of points and we want to know the distance between these points? Well, all we're going to do here is consider all three sets of points. We're going to consider the set of these 2 points. We're going to consider the set of those 2 points. And then we're going to consider the set that consists of the first point and the last point. We're going to find the distance of each of those. It's long and arduous, yeah, but that's how we would find the distance for all 3 points here. That said, if we were to plot these points, we might notice that 2 of these lines are at right angles to each other. And because of that, all we've got to do is find D1 and D2, then we can apply Pythagorean to get D3. Or we can go the long route and find all 3 points. Does that make sense what I mean? So for this reason, when things like this occur, sometimes it will be convenient to go ahead and graph things. Sometimes not so much. That's going to be up to y'all. The point here is that you're going to have multiple approaches to solving the same problem. Cool. Just because I might prefer a particular approach does not mean that that approach is the best one for you. And if you have a better approach, by all means, please use it. I'm not going to be particular about that. I want you to learn the material and understand the material. I don't want you to memorize this. I want you to be able to see inside of it and understand what's actually happening here. Because everything that we're going to talk about in this class has some physical meaning. Like the distance formula, or like the midpoint formula, which is what we're going to talk about next. So if you want to find the midpoint between these 2 points, how would you go about it? We know it's 2, 0, but how would you go about finding that that point was the midpoint? It seems like a logical way of going about it, doesn't it? But not quite, not quite. Why not instead say, we know something about middle values. They're the average of 2 things, right? So why not take the average of your x values to find the middle x, and take the average of your y values to find the middle y? Notice when you do that, -3 plus 3, that's 0, divided by 2, it's 0. 9 plus -5, that's 4, divide that by 2, it's going to give you 2. That brings us to what's called the midpoint formula. The midpoint formula is just the average of your x values or the average of your y values. And if this was in, say, 3 dimensions, you tack on another set of averages for your z values, and so forth, so on, etc., etc., etc. So this idea is just averaging out your points. So I'm going to skip over that. Excuse me. And we're going to go into this idea of translations. A translation just says you've got a set of points, you're translating them. Not in the Rosetta Stone sense of translation, but in the sense of moving it to another spot. So in this case, we're taking this triangle. In this case, it would have helped if I had pointed first, right? In this case, we're taking this lower triangle and we're going to move it over 2 units and up 3. Now, the next case, we're going to move it to the left 3 and down 3. So what does that mean? What does that look like? Well, what a translation effectively does. We really need self-erasing chalkboards. If anybody knows someone in the engineering department, get them on that. That would be so great. But what a translation effectively does, as it says, we've got a point X, Y. We're going to translate it by adding some set of values to it. We call it TX and TY. And this is going to give us a new point. It's going to be X plus TX and Y plus TY. Now notice, if we move to the left, TX is going to be negative. And if we move down, TY is going to be negative. Otherwise, they're positive, right? Makes sense? So in the case of the second set of points, or the second example here, looking at this point down here, or my mistake, up here, we've got 2, 0. We're going to move this down 3 units. So this is going to go to -3. And to the left, 3 units. So this is going to go to -1, right? So this point should be shifted to -1, -3. Coming over here, looking at it, -1, right? And then -3. Makes sense? Having said that, since the last class I ended here, I think I'm going to also end this class here. I'm going to let y'all go for the day. I'm not going to hold y'all for the entire lecture. Today's really just about introducing y'all to me, my lecture style, and what the class is going to be about. If you have any questions, I will stick around for a little while. Feel free to come up and ask. Oh, calculators. Yes, yes. So there was a question about calculators, and I think it was asked earlier, and I totally did not answer it. Calculators. The only requirement I have about calculators, I do not want them to be able to control space shuttles, right? Like, I don't want them to be super advanced high tech. But otherwise, yeah, basic graphing calculator, totally fine. Totally fine.
Okay, so I said that, so I didn't get. Thank you. I actually give you.
So the first thing is I missed part of the syllabus.
So what?
From the first.
Oh, yeah.
Yeah, sorry, I just had to park at the stadium. 'Cause I was
Yeah.
parked.
I gotcha. Basically, the syllabus can be found on course materials. Say what?
I'm gonna read the syllabus and I look at
Okay.
anything else.
The only thing you need to know about the syllabus is that the office hours and the class location and time were wrong. That was the only thing. And the schedule on it is a tentative one.
All right, thank you very much, sir.
Yep, not a problem.
Just want to reach out.
Awesome.
My
I'm
name's
Matt.
Kyle. Sorry I was late.
Yeah, me too.
Oh my God,
We were
guys,
in
you don't
there.
read your announcement? No, just kidding. just
No,
kidding.
because I looked on my email, there was nothing about it, and then I checked my schedule, and it still said Wilmer
Yeah.
Auditorium. And so we all went there. There was no lights
Schedule
on.
says Wilmer?
Yeah, I didn't even have your name on there. like,
Yeah,
as the
there was no
instructor.
instructor.
Yeah,
It
it said
just said
multiple
Wilmer.
instructors.
Yeah.
Yeah.
It does say
where
multiple instructors on
your,
there.
Blackboard says multiple instructors. It did say your name for a while and then I think it changed. But we found it now.
Yeah.
It
Yeah, she
says
was sitting
Wilmer.
outside the classroom and she was like, this room is dark and it was like scary.
Yeah, it was in the basement, no lights on or anything.
I figured the whole thing couldn't be trusted when it said it was spring. So that's when I looked on Blackboard, or I looked on my
Right.
registration banner
Right.
and found it.